Okay, Year 10, welcome to your video tutorial. Today we are going to have a look at how to calculate volumes of solids. Okay, well, first off, volume refers to the amount of space on the inside of a solid. So, perimeter is around the outside. Area is on the inside of a 2D object. When we looked at surface area, we looked at the outside of a 3D object. Volume isn't just on the outside or the surface, we're now looking on the inside. How much stuff is on the inside? Before we can look at volume, we have to have a conversation about cross-section. For most solids or for most 3D objects, there is a shape that runs consistently throughout. That might be going sideways, that might be going top to bottom, that might be going an angle, but there is, for most shapes, for most solids, a shape that runs throughout. This is called the cross-section. Let's have a look at these two totally different shapes. So I've got the Toblerone down here. Now the cross-section of the Toblerone is actually the triangle here. Okay, and that triangle, imagine I cut the Toblerone here. You would still have on the Toblerone this kind of triangle shape, and that triangle is here, and I can cut it anywhere along the shape and you would still have that triangle. Therefore, the triangle is classified as the cross-section. Now there's this weird kind of pull shape that goes around all the way around like that. Now it has a different cross-section. You'll notice that it has a bit of depth. This shape that I've really roughly outlined is the basic cross-section. I can cut this pull at any point of its depth, okay? If I say dropped it by 30 centimeters, it would still have this weirdly bizarre shape throughout. Therefore, that weirdly bizarre shape is called the cross-section. And I need to know what a cross-section is and how to identify it so I can work out volume. Let's look at why the cross-section is so important. Well, for shapes with a cross-section, we find the area of that cross-section and then we multiply it by the perpendicular height to find volume. That one more time. We find the area of the cross-section. Now, with the pull, I'd have to be given it because there is no way I can work out the area of some weird blob. There's no formula for some weird blob, okay? So if I ever got a question like the pull and was asked to find its volume, more than likely I'd be given the area of the cross-section and I'd just be given the height or the depth of the pull and then we're asked to work out the volume. With the Toblerone, however, it is a triangle, so I may only be given dimensions of the triangle and then asked to work out the volume. The first thing I need to do with the Toblerone is work out the area of the triangle. Okay, that's the cross-section. And then multiply it by the height going the other way. Okay, or the height perpendicular to the cross-section. That way, if I take the area and I multiply it by the height perpendicular to the cross-section, I can find volume. Okay, so if you look at this shape here, this actually has a few cross-sections because it's a rectangular prism. But I'm going to take the bottom one because I have both of the measurements pretty easy. Okay, I'm going to use this blue shape I've just outlined of my solid as the cross-section. The height that is in 90 degrees to it is this one here that I'm just drawing in red. That's its perpendicular height. So like I said before in the previous slide, the first thing we need to do is find the area of the cross-section. So the area of the cross-section. Now, first thing you need to do is identify what shape is the cross-section. It is a rectangle, so my formula is length times breadth for a rectangle. And so the area, if I sub in that formula of the cross-section, is 6 by 4. Put equal signs there. 6 fours are 24. Okay, so that's the area of my cross-section. In order to get the volume, I take the area of the cross-section and I multiply it by the measurement or the height that is in 90 degrees to it. In that case, it's 5 meters. So the volume so that's 24 meters squared, sorry. Volume is 24 times 5, which gives me an answer of 120. Now, this is the thing that I want to see in all of your working, and this will be success criteria for today. You understand formulas. You understand how to sub and get the right answer for area. For volume, it is not in units squared anymore because we're looking at how many little cubes can we fit that are, for this example, 1 meter by 1 meter by 1 meter, so that have depth. Our volume ends in units cubed. So in this case, it's 120 meters cubed. Okay, so that's really what I need to be seeing in your answers. Let's have a look at this shape here. Okay, this shape here is a cylinder. The shape that is consistent, or the cross section, the shape that's consistent throughout, is this circle. Okay, I've been given a radius for the circle. So the first thing I need to do to work out the volume is the area of the cross section. How do I work out the area of a circle? Well, you'll have your formulas there, and it's pi times the radius squared. That's how I work out the area of a circle. So it's pi times 2 squared, which gives me an answer of 12. Now it's a decimal point. 56637. Oh, that's as many places as I need. To find the volume, okay, I take that area of the cross section, that 12.56637, and I multiply it by the height that is at 90 degrees to it. So that's this down here, and it's been labelled as 6 centimetres. So I times 12 by 6, which gives me an answer of, that's divided by, times by 6, which gives me an answer of 75.398. Okay, so that's greater than 5, which means 39 goes up by 1. So that changes to 75.40 centimetres, because that's my unit of measure, cubed, because it's volume. 75.40 centimetres cubed. That is my answer to 2 decimal places. That says that 75.4 little cubes that are 1 centimetre by 1 centimetre by 1 centimetre can fit in here. Okay, so always an answer of cubic units, okay, when we're looking at volume. And that's it, guys. That's volume. Things to pay attention to are the height at 90 degrees and finding the area of the cross section.